pretty much it. I really hope you enjoy the SQL workbench, and thanks for reaching out if we've already been in touch. It's good to see you all again. All right, back to you, Doug.
All right, thanks. Actually, real quick, Sarah, before I forget, I forgot to hit the record button until like you were almost done with your announcement. I'm sorry. Okay. You don't have to do it again.
No, I will.
Yeah, but we are recording now, I promise.
Yes, class. For the first time, I will be saying this information to you. No. So the due date, the hard stop for all assignments is November 16th, which is a Monday. And we just want to make sure that we know who's moving forward to graduation on November 18th. And also because liftoff starts a week later on the 23rd of November. So to that end, if you're having any concerns, any doubts, please reach out to me. That's what I'm here for. I'll be posting my You Can Book Me in the announcements channel. And so you can just go there, schedule a meeting on my calendar. And if you don't find an availability there that works for you, just message me on Slack. And you can also message me throughout the duration of this class or on Mondays in general, because I'll be here from 5:30 to 8:30. So, all right, signing off.
Great, thanks. Got it that time.
Great, thanks, Doug.
Appreciate it. All right. Let me just get set up here for today's class real quickly. I'm very excited about today's class. I'm excited about every class. I think you probably know this about me by now. I feel like I say that I'm excited about class a lot. It's true. It's true every time. And it's true tonight as well. I really, 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 really enjoy working with databases. I'm a back-end guy. I feel like we've had this conversation before, but I'm definitely somebody who feels at home on the back end. And so working with databases, getting information into and out of databases is like right up my alley. It's something that I have spent quite a bit of time honing my skills in this particular area. So I'm really excited to continue having these conversations with you about databases. We're going to go through today's exercise. I'm particularly excited to talk to you about not just joins, but subqueries. I have a special place in my heart for subqueries. I really love subqueries. I think they're really cool. And we'll kind of talk about the differences between joins and subqueries. I also have some strong opinions about some of the stuff that was presented in the prep work that may, well, maybe I'll save that for a bit later. But any information on when or how to sign up for liftoff? I don't have that information. Sarah should be getting you that information at some point. I do not know when that will happen, but when it does, there will be neon lights and sirens and many different beacons leading your way to that liftoff form. So you won't be able to miss it. Yeah, I'll definitely keep everyone posted about that. We have not forgotten about liftoff, that I promise. So yeah, good question. All right, let's do some database stuff. So I'm going to kind of breeze through the first couple of steps. I'm going to do them, of course, because I have to, but I'm going to breeze through the first couple of steps because we've already kind of done this stuff before. But if I go too fast or you're confused about something that I've done, please ask me to stop, slow down, go back. Whatever you want to see is what I want to show you. So I've got MySQL Workbench loaded up. Oh boy. Oh, what was my password? That wasn't it, I guess. What was my password? Oh, hit save button. That wasn't it either. All right, third time. Oh wait, it says it's opening. Okay. Please stand by. I'm standing by. What? What are you doing to me? Oh God, it just crashed. Hang on, let me turn off something real quick. Here's something that I learned actually a couple weeks ago that I never told you all about. I use my computer's mobile hotspot a lot, and I know I'm showing you my network password for my mobile hotspot. If you know where I live, you can come hop on my Wi-Fi network, but you don't know where I live. At least I hope you don't. This causes problems. This causes lots of problems. So if you're having trouble connecting to your database, or I was having trouble connecting to Gradle and Swing, it was because of my mobile hotspot. Turn it off. Turn it off. All right, let's try this again and see if I can not crash this time. Oh, it's because I saved my password, huh? Now I have to go back and tell it to forget the incorrect password that I typed in. Is that it? That's fun. What is my dang password? Clear. Close. All right. Is that it? No, that's not it. What is it? That's not it. What else could it be? Oh, okay, I got it. Sorry. I have too many passwords. All right, cool. Sorry about that delay. Let me close all these tabs because we are going to 1, 2, 3, 4. Yeah, that's it. My password is password backwards. Password backwards. And if you believe that, I've got an arch I'd like to sell you. What was I doing? I was spacing out because I was too busy thinking of dumb jokes. We're going to create a new schema for today's exercises. Yeah, with an at for the A, 3 exclamation points. We're going to create a schema for today's exercises. Does it tell us what they want us to call it? It wants to call it garden. Okay. We're going to make a schema called garden, kind of going off the gardening theme. I actually have a garden out front that is overgrown and filled with weeds, but it's the end of the season, so don't judge me, right? Click the apply button down here to make my brand new schema called garden. It's got no tables in it yet. That's what we're going to fix next. I'm going to go to the GitHub repo. Again, if I'm going through this too fast, let me know. And I'm happy to go back. I'm going to download these files here. No, I want to, no, I can't just download the folder. I can download like this. Okay. Extract. And the lesson 15 exercises are probably the ones that we want since I'm doing the lesson 15 exercises. So now we need to, they want us to use the table importer, correct? Just making sure, yeah. They want us to use the table import wizard. Oh wait, we need to create the tables first. I'm getting a step ahead of myself. This is where we need to start writing some code, yeah. So cool, here we go. Let's create some tables. So they described each table to us, but it's now up to us to come up with the proper SQL statements to create these tables. So we want to think about not just the columns that each table contains, but also, since we're talking about relationships a lot, we want to think about how these tables relate with each other and how we can set up those relationships. So that's something that's going to be, a pretty big topic for us today. The first table on our list is the plant table. So we can go ahead and make a new SQL query here. Create our plant table. And every time we create a table, we've got some choices to make about the columns, right? Plant ID, they just tell us the name. They don't tell us anything else about the type or any other options that it should be, but we see that it is in fact the primary key, right? Which, since it is the primary key, I talked about this last time, that kind of already tells us what we need to know about the options for this particular column. Do I need the parentheses there? I don't think I do actually. So we're going to mark it as the primary key. We're going to mark it as an integer. And there's one other thing that we use with primary key columns. What's that? auto increment. Yeah, auto increment. Underscore, right? Sorry, I'm running on very low sleep today, which is not terribly unusual. What am I forgetting? I don't need the parentheses here. I don't think I need the. I know I need the comma. I always forget the flipping commas. You actually don't need the semicolon either. I do need the parentheses. Primary. Oh, it wants the type first. That's what I did wrong. It wants the type first. There we go. Got it. Thank you. Perfect. Awesome. Yes. Yeah, the order of these does matter. It always wants the type first, and then other optional descriptors can come afterwards. So I mentioned this last week, right? But this is pretty much how our primary keys are always going to work. That used to not be true. And I mentioned this because you may still run into some older databases where primary keys don't look like this. It used to be recommended, and this was a recommendation even as recently as 10 or 15 years ago. When I first took a databases class in college, which was probably about 10 or 15 years ago, the advice was to try to use what's called a natural key. So a prime example of a natural key is something like a social security number, right? A number that can be used to uniquely identify every person in the United States, at least, would be a social security number. But there are some problems with that. For example, I mean, that key needs to uniquely identify every record, but social security numbers, they get reused, they get stolen, they actually can change, right? So while back in the 90s, using social security numbers as a primary key for your employees or your students or whatever table you had was common practice, we quickly figured out that that was not sustainable and caused lots of problems when people had to change their social security numbers for various reasons. And so that is no longer the accepted advice. Now the advice is to create an auto increment primary key. You might hear this referred to as a, oh, what's the word? I just had it on the tip of my tongue. Surrogate key. Is that right? A surrogate key? I think that's right. But anyhow, you may still run into some databases where they are using things like social security number or student ID numbers or things like that as primary keys. But yeah, that's a big no-no these days. So a little bit of a history lesson for you. Sorry for the tangent. All right, plant name, which will contain the name of the plant. That seems easy enough. But we do, unlike Java and JavaScript, we have a decision to make when we talk about strings, right? Using a varchar, and then we have to tell it the size here. So what are we thinking for plant name in terms of sizes? Anybody have any suggestions they want to toss out? Wow, a wide range, 20, 75, 50, 12. Yeah, a wide range. 40, bingo, that's a bingo. I don't know. Pi. Nope. So yeah, I think bigger, if you give me a big number and a small number, I'm probably almost always going to choose the big number within reason. It can be too big, right? But bigger is usually better than smaller, especially if you're using varchars. Bigger values aren't going to hurt you. There's a different type of string called just a char, not a varchar, that you may see as well. That is slightly different. Does anybody know the difference between a char and a varchar? Yeah, that's right, Dan. Fixed length. If I have a variable, if I use varchar as my string type, if I give you a plant name that's only 10 characters, it's only going to take up 10 characters worth of space. If I give you a plant name that's 20 characters, it's only going to take up 20 characters worth of space. If I use the char type instead of varchar, if I give you a plant name that's 10 characters, it's going to take up 80 characters worth of space. If I give you a plant name that's 20 characters, it's going to take up 80 characters worth of space. It actually adds spaces onto the end until it hits that length, so that every string is exactly the same size in that column. So Tom, asking the natural follow-up question, when would you use char over varchar? Varchar is good if you're concerned about saving space. Characters using just char is good if you're interested in optimizing for efficiency, because actually it's faster to go through a database if you know exactly how long each string is going to be. So it's an optimization to use this. But also there are certain cases where this just makes more sense. For example, if I'm doing state codes, right, like you put on an envelope, those are all 2 characters long, and they're never going to be anything different. So this makes a lot of sense to use a char instead of varchar for that, right? So you kind of have to think about what the ultimate goal of your information is. Yeah. But I would say for a lot of things, varchar is probably the right choice. And 80 sounds big, but as somebody mentioned a while back, if I'm using like scientific names of things, may not actually be as big as you might consider. There's something else that when does varchar length get out of hand? I mean, the only downside of making this varchar absolutely huge, right, that I can think of, there might be others, but the only downside of making this number absolutely huge would be that you're now allowing somebody to put something that's up to 2,000 letters long into that column, which is going to take up a whole boatload of space, right? And B, probably not going to be a correct plant name at that point, right? It's probably an invalid chunk of data if it's that long. So having some kind of length at least, kind of sets a boundary. Like it might be 255. Yeah, there are ways around that 255 limit for sure. I don't know what the actual 65,000. Yeah, I don't know what the actual limit is. I'd have to look it up in the documentation. But yeah, I think 80 is reasonable. There's another option that that is also worth thinking about for basically every single column that you create that has to do with a word that starts with an N and rhymes with hull, seagull. Yeah, we're looking for null. So every single column that we have in our table can either can allow nulls or we cannot allow nulls, right? There's a not null property. I was looking for this in the text over the weekend when I was prepping for class. I was looking for a discussion about this in the text, and I think it was mentioned just very briefly in one place. But this is a very important decision. For every single column, you should really be asking yourself, right? Is it okay if I allow gaps to occur in this column, or does this information absolutely have to be present? So, what good is a plant if I don't know what the name of the plant is, right? What good is a plant if I don't know what the name of the plant is? So I can, by saying not null here, I can say that you absolutely have to specify what this is. That's a common question that I'm going to ask for basically every single column that I put in. I know the prep work, the textbook doesn't really emphasize that so much, but it really is a big deal. It helps limit errors. It also, I mean, it's data cleanliness, data quality is a really big thing. If you ever get into the field of data science or data analytics, data quality is a huge deal. It's just an absolutely massive deal. And so having holes in your data where information is just missing is obviously very, very bad. It's not a good thing. You want to avoid it if at all possible. So this is one way to try and protect yourself from that at least a little bit. That's not to say that you shouldn't just slap this on every single column. I don't think that's the right takeaway, right? Some columns, it's truly okay if that data is missing and it will not hurt us. And we should allow that to happen in those situations. But other columns, would be disastrous if we had nulls. I think plant name is a pretty critical piece of data, right? I think marking it not null is probably a good idea. Personally, that's my personal opinion. You're allowed to disagree with me as always, and As long as you can justify your answers or why you disagree, then I'm not gonna complain or argue with you about it, right? It all comes down to justification. All right, cool. Zone is an integer for the hardiness zone where a plant will grow best. All right, cool. Zone. They said it's an integer. This one I feel like could be null. Again, you're welcome to disagree with me, and if a lot of you disagree with me, I'll happily put it on there. But I feel like that one could probably be left out. You know, season is a string that specifies the season when the plant blooms. All right. So varchar, I suppose, and for this one, we have the length question again, right? Would season be a good one for an enum? Potentially, yes. Potentially, yes, would be a good one for an enum because there are only so many seasons, right? There are only so many seasons. In fact, there are 4, I believe, right? So let's refresh our memories on enum syntax here real quick. Hey-oh, Shelly with the zinger. Here we go. Enum, and then we just, oh yeah, very similar. Just wanted to make sure that I got the syntax right. What season is it right now, everybody? Yesterday, I feel like it was a different season than it was today. Am I the only one that feels that way? I mean, this is all we really need, right? That's all we got. But for completeness sake, put those in as well. Yeah, we got some rain. All right, so let's go ahead and summer 2. Let's go ahead and run this to create our table. Refresh, make sure the table's there. Whoops, I'm in the wrong one. Remember to double click the schema that you're working with because I just created this plant table in my movies database. Whoops. So now I have to switch to the proper database, the garden database, and run it again. My bad. If that happens, right, of course, you can then go down here and right click and drop the table to get rid of it. Or you could type out the query if you really want to. Drop table, right? So-and-so. All right, cool. Let's make another table. The seeds table. Seeds has 5 columns. All right, so we can kind of skip through, just trying to pay attention to my time here. Seed ID is going to be a primary key, so we're going to use the typical primary key properties, right? Now we have expiration date, which is going to be of the date type. All right. Expiration date is going to be of the date type. And then we're going to do quantity, which is an integer. Quantity, which is an integer. We've got reorder, which tells us if we need to reorder that seed or not. All right, so that'll be a Boolean. I ran that by clicking the little lightning bolt up here. That's how you run these SQL execution. That's how you execute your SQL queries. And then here we go. Plant ID is a foreign key that connects seeds to plant, right? So this is our first example of a relationship. I'm connecting the seeds table to the plant table, right? Connecting the seeds table to the plant table. What kind of relationship are we creating when we do this? What kind of relationship? Yes, it is a one. Is it a one-to-one? It's a one-to-many. It's a one-to-many. It is a one-to-many. And I've got some stuff to say about that, but before I forget, I'm going to scroll up and answer this question from Lisa, who asks, for the not null, does it matter the type? It does not matter the type. You can mark anything as not null. And I was waiting till I created all of the columns before I asked that question, but that is something that we should think about as well. But back to the topic of relationships. If you create a relationship between, here's a not so secret. It's not really a secret. It's just how these things work in general. If you create a relationship between two tables in your database, it is a one-to-many relationship. That is, if you create a primary key, foreign key relationship, that is a one-to-many relationship. In fact, I would argue that every relationship that you create is a one-to-many relationship in a database. There are other types of relationships. The book mentioned 2 other types of relationships, right? They mentioned a one-to-one, which is what Will said a few moments ago, and a many-to-many relationship. Of those relationship types, this is one of my strong opinions for the day, where I kind of disagree with the book a little bit. I don't believe in one-to-one relationships. I don't really believe that that's a thing. A one-to-one relationship is really just a column within a table. If I have a one-to-one relationship, what I really have is something that should have been a column inside of this table. That's a one-to-one relationship, in my opinion. So we don't need to explicitly define that. The way we define one-to-one relationships is by putting columns into our tables. Many-to-many relationships, however, very much do exist, and many-to-many relationships are expressed as 2 one-to-many relationships, typically using something called a linking table, which I don't know if we're actually going to see an example. I don't think we're going to see an example of that today. But that is, in fact, how a many-to-many relationship works, is via an intermediate table called a linking table. At some point in time, maybe during the next catch-up day, I can do a more detailed example of what a linking table looks like, what a many-to-many relationship looks like. But for now, I think a good thing to keep in mind is that if somebody's talking to you about relationships in SQL, it is a one-to-many relationship. It could be a many-to-many relationship, but even if it is, the code is going to express that as 2 one-to-many relationships. So anytime you create this primary key, foreign key situation, you're really creating a one-to-many relationship. So along those lines, which side is the one and which side is the many of this relationship? It's called one-to-many. So which side is the one and which side is the many? Anybody have any ideas about that? The plant is the one side. That's right. And the way that you can reconcile that in your mind, remember that plant ID is the primary key of the plant table. So the primary key side, wherever the primary key resides, since the primary key is unique, that is the singular side. That is the one side. Here, plant ID is not the primary key. It's the foreign key. There's no restrictions on whether this has to be unique or not. It can show up many times. The foreign key is always, always, always the many side of the one-to-many relationship. So think about what that means in practice. If I have a plant in my plants table, its ID number can show up in this seed table many, many, many times, because I can have many different sets of seeds for the same plant, right? One plant can have many different sets of seeds, right? You can say it out loud in English and see if it makes sense or not. All right. Any questions about that? I know it's a potentially confusing topic. If there are no questions, my next question for you then is, how do I actually hook it all up? How do I actually say this? How do I make this relationship happen? I have to say the words foreign key, right? So where do I say this? Down here? References plant plant ID. Comma? Not quite. Oh, plant ID in parens. There we go. Got it. So I declared a column as normal, and then once I'm done declaring my columns, I declare foreign keys. I declare my foreign keys. No comma. If I take the comma out, it gets mad at me. Not on line 7, yeah. Not on line. I appreciate you looking out, though. As I mentioned multiple times, I always forget the commas. I don't know why. Commas are my kryptonite when it comes to databases. So this is going to create a foreign key that references the plants table. Let's run this statement and make sure that it works. It does, right? Let's refresh and make sure that our table exists. It does. Can we see that it is in fact a primary key? The primary key foreign key relationship works. I see that there is a foreign key listed here now, right? There is a foreign key. Oops, didn't mean to do that. We had the semicolon conversation last week, but yeah, just to recap, they are technically optional with the threat that they may become non-optional at some point in the future. I have, I suppose, what would be considered a bad habit by not including them, but they are technically optional for now. For now. All right, we got one more table to make before we can start writing some joins and subqueries. Third table is garden bed, and we've got another foreign key actually to the plant table as well. So here we go. Interestingly enough, what's the? I look at these. I've got space number, which will increment as we plant new plants. Date planted, doing well. Plant ID. What's the primary key of this table? Space number, yeah, probably space number. All right, cool. The reason I asked that is because for the previous two, right, plant ID, seed ID, that seemed like we had a thing going with the primary key, but this one they didn't call it that. They called it space number. So I thought that was interesting that they switched it up on us a little bit. But yes, I believe that is in fact our primary key in this particular case. And then date planted, which is going to be a date. So this is actually working out well for me in terms of, oh, I forgot to ask the not null question. Shoot. Well, it's too late now. I'll ask it for this one. Doing well. Forgot to ask. Oh, yeah, this table name too. Thanks. I'll ask the not null question now. Obviously, primary key cannot be null, or I hope that's, I said it was obvious. Maybe it wasn't. The primary key cannot be null. It is required, right? But of the remaining columns, which ones would you argue are not allowed to be null? Actually, foreign key is the same thing. Cannot be, well, actually, let me pause. That's not necessarily true. I'd say more often than not, the foreign key is not going to be null. But there are exceptions to that rule that we probably aren't really going to get into. But anyhow, so really of these two columns, date planted and doing well, which one of these might we consider to mark as not null? Anybody have any opinions? Date planted. All right. Happy to do that. I think that makes a lot of sense. This one I feel like could be null without too much trouble. Doing well. Let me just do one more check to make sure everything looks okay. I think it does. All right, let's do it. Everything succeeded, so I should be able to refresh. Boop. And I've got my 3 tables. Awesome. Got my 3 tables. Okay. Before we go on to the next step, I want to show you something that I don't believe was in the prep work. A lot of times in order to get a good idea of what a database contains and kind of see the lay of the land. It can be useful to see what's called a diagram. You might hear it referred to as an ER diagram or something along those lines. And MySQL Workbench can generate that diagram for you. So if I go to database and select reverse engineer, I can tell it. So first I have to provide my login credentials, right? All right, did I forget my password again? What's my password? It's password backwards, right? So I've logged in. I'm going to select which schema I want to include, which is the garden one that I'm working on. If I hit next, it's going to grab everything out of there. Import MySQL table objects. Yes, that's what I want to see. And it's going to do some stuff. And now I can actually see here is a diagram of my database, including the relationships between the tables. So I can see visually all of the columns, their data types, right? And the relationships, where the relationships are marked. This is the one side with the two little lines, and then the side with the fork. I don't know how well you can see that on my screen. This side has a little fork on it. That's the many side. So that's where the foreign key is. And if I hover over it, it actually shows you, right? It highlights the primary key and the foreign key, right? And even marks a little key symbol next to the primary key. If I see something, so by these other columns, I see these little diamonds, and some of them are filled in and some of them are not. The ones that are filled in, those columns are the ones that I marked as not null. The ones that aren't filled in are allowed to be null. So you can kind of get a good lay of the land as far as your database goes. Get a good feel for what's connected to what and how, which I find to be very useful for what we're going to be doing in a little bit, which is writing queries to retrieve data out of a database. It's very important to know what columns are available to you and how these tables are connected when writing your queries. So I find this diagram to be very valuable when doing that. How did I do it? I went up to database and hit reverse engineer, and then just, you know, all I really did was type in my password and click next a bunch of times. I had to select the schema that I wanted and then click next a bunch of times. Can you edit things? I believe you can. Yeah. So if I double click one of these, it pulls up this window down here, and yes, I can in fact edit. Can in fact edit these things, right? Which, to be perfectly honest with you, I'm not a big fan of editing tables and things in this way. I prefer to write out the commands, the SQL commands myself, although I don't really have a strong justification for it other than that's just how I like to do it. Regardless of whether you are considering using a tool like this or not, I think that it is very important to understand the SQL commands and know how to write them, because you may not always have access to a tool like this, or the tool may not do exactly what you want it to do, and you may find yourself in a situation where you have to write the query yourself. So while I think I can certainly see how this would be very valuable, it's certainly not a replacement for knowing how to write the queries yourself. So yeah. So I'm going to leave this open while I go back to here and import the data and start writing some queries. So now that we've created our tables, we should be able to import the data. So we're going to use the table import wizard, which they link us to the documentation. Well, kind of the documentation, right? So I'm going to right click the plant table and go to table data import wizard. Go find the folder that has the stuff. Plants, open. Next. Use existing table. Yes, that's what I want to do. Next. It's asking me to match, right, the columns of my table to the columns that exist in the CSV file. There's not a whole lot. That's okay. Next. Next. Go back. What did I forget something? What did I forget? Mismatched. Check my columns. Oh, it is mismatched. Thank you. You're right. Thank you. I just assumed everything was going to work out okay, and it was not. Thank you. You saved me a bunch of hassle. All right. It tried. It tried, but you know, it's a computer. And just to check and make sure that everything looks okay, we can open up the table and see that, all right, cool, yeah, that looks good. Now we can do that for the other ones as well. All right, import. This is the seeds table. Use existing. All right, check these this time. It also got it wrong. That's okay. Oh, one other thing. Well, yeah, let me do this first. 2 records. That's good. Garden bed is the last one. Okay. And we're going to go with date, doing well, plant ID. There we go. Awesome. All right, I should have data in all my tables now. Notice that doesn't change my diagram at all, right? The diagram doesn't care about the data that's contained in the tables. It only cares about the structure. It only really cares about the structure. So what I just did doesn't affect the diagram at all. This is just letting us see the high level structure of our database, which will come in handy as we try to write the upcoming queries. So let me pause here for a moment, see if anybody's got any questions before we start to write some queries. I know that was kind of a lot just to get up to the point of writing some queries, but had to make sure to get that prep done. Okay, so they want us to write a series of joins. We're going to do the inner joins and the outer joins and the full join, which are all very similar queries, right? So really, we're just kind of exploring the differences between these query types, which I think is a good little exercise. First thing that it wants us to do is, excuse me, I apologize, use a join between seeds and garden bed to see which plants we have seeds for and are in our garden bed. And so the first thing that I'm going to do when faced with a prompt like this, I'm going to go to my diagram. How do I connect from seed to garden bed? And I can see that there's no direct relationship between those two tables, correct? There's no direct relationship between those two tables. In order to answer questions that involve both of these tables, I have to follow existing relationships, which means I have to bring in this third table. Even though I may not want any data out of this table directly, because this is the table that connects between these two tables, I need to include all 3 of these tables into the query that I'm about to write. All 3 of them, right? That's why I think these diagrams are very valuable, especially consider the case that this is actually a fairly small database. There's only 3 tables. It's not unusual for databases to have dozens of tables in them. And so writing those queries, while obviously a lot more complicated, being able to see the relationships between the tables and how they hook up with each other is going to be a lot more valuable when you've got a lot of tables to sort through, right? So I always try to trace a line. I want data from this table and this table. Can I trace a line from those two? And the answer is yes, I can, but I have to rope in this third table along the way. So let's go ahead and see if we can write that query to make this happen. So I'm retrieving data. What kind of query is that if I'm retrieving data out of a database? What kind of query? That's a select. So when I write a select query, again, to kind of recap from last time, I'm going to write select and from out first. I call this the scaffolding. That's not a technical term. That's just what I call it. I make myself a little bit of scaffolding. I try to decide if I need any of the other clauses, like a where clause or an order by clause. If I know that I need those, I might add those in now as well. But if I'm unsure, I can always add them later. I know that I need at least these two things, right? And I typically like to start with from. There's nothing that says I have to start at the top and work my way down. I usually like to start with from. I like to know which tables I'm pulling stuff from first. So, all right. So I want to know, right, inner join from seeds and garden bed to see which plants we have seeds for and are in our garden bed. Let me look at my diagram one more time here before I do this. So I see that plant ID hooks up here and then plant ID hooks up here. So I suppose there's an argument to be made to try and skip the middle table and go directly from here to here since they both contain a plant ID. Did any of you do that? That's what you did? Yeah. I'd be interested to see if there's any difference between that, actually. I'm kind of at a fork in the road trying to decide what to do next. I think it's important to see that you can join more than two tables together at once. So I'm going to write a 3-table join here just to show you that you can and show you what that would look like. And we can also experiment with the 2-table version of this and see what differences exist, if any. So to do a 3-table join, we just have to pick 2 of the 3 tables, right? So I can start with garden bed and plant and join them up. On, and then we specify the relationship, garden bed, dot plant ID equals plant dot plant ID. All right. So right now I've joined 2 tables. I've joined garden bed to plant, but what I really ultimately want to get to is the seed table. So in order to do that, I would say join seed on plant.plant ID equals seed.plant ID. So I'm joining the result of this join to a 3rd table. This is a 3-table join, joining all 3 tables together. Not only that, but it's an inner join. Some people might type out the word inner here, but if you leave the word inner off, it's implied. So these are, in fact, inner joins, even without the word inner. And what column might we want to pull? Sorry, does it tell us what column we want? To see which plants we have seeds for and are in our garden bed. So what did you put up here for column then, I guess, is my question, right? Plant ID, date planted, seed ID, space number, quantity. All. All right, let's start with this and see what happens. Okay, so here I see seed ID, I see space number, I see quantity. And you can see that seed ID 2 appears to be the only seed ID that I see show up. And Lisa, I'm very glad to hear you say that. Plant name might be good. And here is one advantage of doing things the way that I did them with the 3-table join. What table does the plant name come from? It comes from the plant table. If I don't include this as part of my join, I cannot pull the plant name. So if you did a join directly from here to here, you've got no way to pull the plant name out, right? You've got no way to get that plant name data. So that alone could be justification enough to rope in a 3-table join, right? That alone could be enough to justify pulling in that 3rd table tulips. It appears that tulips are all that we've got. We could do a quick visual inspection, right, of the data to make sure that that's in fact the case. I see tulips. Let's see, plant ID 4-5. Garden bed has a bunch of 5s for plant IDs, right? But no 4s. And then the plants table, which I have here, 5 is tulip. Yeah. 5 is tulip. So of what question have we answered, right? The question that we have answered is this. Of the plants that are currently planted, currently in our garden, which ones do we have seeds for, right? That's the question that we have answered. There might be other plants in our garden that we don't have seeds for, and there might be seeds that we have that are not in the garden, right? Those things might be true as well, correct? But of the plants that we have planted and have seeds for, tulips are the only ones that fit that category. And to really make this nice, Corey, we could put distinct up here so that we just get a nice list of here's all the plants that we've got, right? If I make this a 2-table join, I can't include the plant name, but I actually think that you would get the same information back. I actually think you would get the exact same information, right? You would still get the information that tulips meet that criteria, but you just wouldn't be able to see that plant name without doing a little bit more digging. Does that make sense? Why roping in that 3rd table gives us access to the plant name when we wouldn't otherwise have it? Yeah. And we got to see a 3-table join in the process. I think that's good too. I think that's good as well. And so the next thing that they ask us to explore is about outer joins, of which there are 3 types. There's a left join, a right join, and a full join. So we can see that we're getting into some directional things, right? Left and right and full and all that stuff. Before we get into those, let me ask you real quick a question. Does the order that I put these 2 tables here matter? Or in other words, if I flip this with this, does that matter? It doesn't. For an inner join, this does not matter. This does not matter. In terms of the results that I get back, it does not matter. I get the exact same results back regardless of the order that I put these on. For outer joins, though, that's no longer true, right? For outer joins, that is no longer true. So if I want to see, they want us to now use a left join to see all of the seeds that we have and any matching plants in the garden bed. So we want to see all of the seeds and any matching plants that we might have, right? In the garden. So in order to do that, we may have to reorder things a little bit. If they really want us to use a left join, right? Which table needs to be on the left? If we want to see all of the seeds table needs to be on the left. And now the positioning does matter. And you can see that seed is the last table that I've joined. So actually we need to swap seed with garden bed. I hope it makes sense as to why that is the case. And not only that, but I need seed to be over here. And now I can say left join, right? So if I run this, what am I going to see? I'm going to see all of the seeds, correct? All of the seeds, whether or not they are in the garden bed. And tulip. Tulip is what I've got. Is that all the seeds I have for real? No, I should have had another one. What did I do wrong here? Oh, I think it's the 3 table. This should probably be a left join as well. That do it? Yeah, there we go. Daffodils. Yeah, they both need to be left joins, right? They both need to be left joins. And to consider why that is in fact the case, consider that although this left join keeps everything from the seeds table, I did an inner join after it. I did an inner join after the fact, which would filter out anything that does not match. So it's almost as if the left join doesn't matter at that point, since the inner join kind of canceled it out. I hope that makes sense. I hope it does. But to truly see, so this actually doesn't quite answer the question. I look at these plant names and I'm still left with the question, which one of these are actually in my garden bed and which ones are not? How would I answer that question? How would I see definitively which ones are in the garden bed and which ones are not? I'd have to include a column from the garden bed. So something like space number would work. And if I run this again now, right? Well, distinct is not really helping me anymore, but that's okay. If I run this again now, I can see that tulips appear in these space numbers, right? Daffodils null, which means that it does not appear in the garden bed table. That's how an outer join works, right? Include everything from this table. If you don't find a match, fill it with null. Fill it with null. Does that hopefully make sense? So with that in mind, let me show you a little bit of a more common use for an outer join. A more common question that I might answer with an outer join is, what plants do I have seeds for that are not currently in my garden? Looking at this, I can tell you the answer to that is daffodils, right? I have seeds for daffodils, but they are not currently in my garden. But I could actually write a query to tell me that as well. I could say where space number is null, right? It's very, 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 very common to see a left join, an outer join used with a where clause like this to locate the null values so that I can filter out, here are the things that don't have a match, right? What do I have seeds for that are not currently planted in my garden? Oops. There we go. Daffodils. Daffodils. This is a very common use of an outer join. And you know what? I'm going to go over my time tonight because I still want to get through the outer joins and the subqueries at least. So if you need to take a break, please take a break. But I'm going to try to hold it to at least 15, 20 minutes, but I am going to go over a little bit. Just a heads up. Try to keep it don't want to go over too much. So then the next thing that they ask you to do is to write a right join. And so, you know, I could switch these to say right and take this off and run this. And we can take a look and see. So in order to see, you know, what doesn't exist here, I need to include something from the garden bed table this time, right? I'm sorry, from the seed table, right? So instead of space number, it might be better to do like seed ID. And now with the right join, I can see that, all right, with tulips, I've got seeds, but for the hostas, the dogwoods, and the hydrangeas, I don't actually have seeds. They're nulls. So this right outer join is telling me that I don't have any of these seeds, even though these things are in the garden right now. That's the question that we've answered. And I could use a where clause, much like I just did in the prior example, to help me, you know, filter this down even more. But the thing I wanted to mention about using right joins is that you almost never see them in practice. It's just a convention. It's an agreement that we have come to that if you truly need a right join, you should flip the order of your tables and do a left join instead. Okay. This should be equivalent. I just flipped the order of my tables and turned it into a left join. This should be equivalent, and if I run it, it in fact gets me the same data back out. So that's just a convention, right? Right joins aren't incorrect. They may get you the proper information that you want, but people have generally agreed that to keep things consistent, we're always going to write left joins. If I truly want a right join, I'll just flip the order of the tables and write it as a left join instead. So if you do end up writing a right join, it's not necessarily wrong. The computer's not going to judge you, but other people might. That's all I wanted to bring to your attention. Other people might judge you a little bit if they see you writing right joins. Flip the tables and make it a left join. Just one of those things, one of those conventions. The last type of outer join is a full outer join, which is sort of a left-right combo, right? What did I do wrong there? Oh, no, that's not right. What? Full join. I'm doing something really dumb, but I don't know. Unknown column garden bed.plant ID. Clearly I'm doing something dumb. Oh, to use you. Okay. Full joins actually are supported in other versions of SQL. I've used them plenty of times in Microsoft SQL Server, for example. I've used full joins plenty of times. And Oracle's database, I believe, also lets you do full joins. Yeah. But that does give us a chance to talk about unions, which are actually, I think, a little bit of a different ball game than full joins. They're not directly comparable, right? They're not directly comparable. Yeah, it does say full joins. Unions and full joins. So a join is taking two tables and sticking them side by side, right? A union is taking two tables and sticking them top to bottom so that the columns line up, right? A join is taking two tables and sticking them side to side so that the rows line up, right? While unions are useful, I don't know how you would replicate a full join with a union. That doesn't seem possible. I don't want to say it's not possible, but it seems difficult. All right, let's do a couple subqueries, and then I'll shut up and let you get to the studio for today. So here they are, mentioning the problem that I already solved by doing a 3-table join. But that's okay. The nice thing about subqueries is that many of them can be written as joins and vice versa. If I have a join, I can often, not always, but often write it as a subquery. And if I have a subquery, I can often write it as a join. So I can convert back and forth between the two. And not only that, it's possible to use a join and a subquery in the same query, right? So I think what they're kind of trying to get us to do here is to approach this from the case of joining two tables, the plants, not the plant table, the seed and garden bed tables directly. That's very heavily implied here, right? And then using a subquery to get the information that we're missing. So I'll play ball. I'll play the game. Let's see. Open the query tab and copy it into a new query tab. Once you have your inner join set up in a new query tab. Why? I'm not sure I understand why that is the case. Anyhow, They actually want us to use a join and a subquery. So I'm going to try and do a little bit of mind reading here on what I think they want us to do. I think they want us to do something like this, which sounds to me is like how a lot of you solved this anyway. This kind of join will execute, as I'm sure that you noticed when, oops, except I can't do plant name anymore. This kind of join will execute, as I'm sure you noticed. The thing that gives me pause is that there's no direct relationship between those two tables. And we actually have a name for that. It's called an ad hoc join, or an ad hoc relationship. When there's not a direct relationship between two tables that you're joining together, it's called an ad hoc, which just means that there's no direct relationship connecting those tables. It's not inherently a bad thing, but it's definitely a situation where I would just pause and say, do I really need this ad hoc join here? Or is there a way to use existing relationships to get me what I want? And we've actually already seen that there is a way to use existing relationships to get what I want. I just have to do a 3-table join, right? But if we really, really, really want to use the ad hoc join between these two tables, skipping this one, we can still use a subquery to try and pull the plant name out of here as well. So let's see if we can pull that off real quick. So here's what we started with. And what I really want is to see the name of the plant list here as well, right? So where am I going to put my subquery? Did anybody figure this one out? Because subqueries can appear in a few different spots. So where am I going to end up sticking this subquery? Anybody have any ideas about where the subquery is going to go? Anybody figure this one out? Oh, I'm starting from the wrong place. Write a query that gets the name of the plant by joining the plant table on the results set of the inner table. I should have read this sentence. Sorry. Write a query that gets the name of the plant by joining the plant table on the results set of the inner join. Gotcha. Right, a query that gets the name of the plant by joining the plant table on the results set of the inner join query above. That actually, I think, is just a 3-table join. Am I missing something here? Joining the plant table on the results set of the inner join query above. Wouldn't that just be a 3-table join? Am I crazy? I feel like I'm crazy right now. But they mentioned subquery here. Now I'm confused. Okay, well, I'm just going to do it my way then, since the instructions are throwing me for a little bit of a loop. So subqueries can appear in the select clause or the from clause, or they can even appear in the where clause as well. For this particular case, we probably want to put the subquery into the from clause. From where? I guess something like that. Is that going to work? It might. And then I would put plant name here. No, that's not going to work, is it? Oh, from plant. Yeah, and then plant name. Let's see if that does what I think it's gonna do. Yeah, I didn't think that was gonna work. I feel like I'm barking up the wrong tree here. I feel like I'm barking up the wrong tree. And I gotta be honest, it's because I'm a bit confused by the wording of this question. So I'm gonna put a pin in that one and do number 2 instead, because I don't want to take up any more time, but I do want to do a subquery. So our plant table is so large, we have no idea what the plant ID for a hosta is, but we know there's definitely a row for the hostas. All right, we're going to write a query that will insert a new row into our seeds table. This new row is going to show that we received 100 hosta seeds. And for the plant ID, we're going to use a query inside the insert statement. All right, cool. I like this one. This one makes a lot more sense to me. They even give us the query, right? Select plant ID from plant where plant name like hosta. Yeah. They even give us the subquery, so that's going to save us some time. Insert into seeds. And then we have to list out the columns that we are inserting into, which is going to be expiration date. Quantity, reorder, plant ID, values. Does it say what to use for these other values? It says 8/5/2020, so no need to reorder. Here we go. Boop. 100 of them. False. And then this is where we would put the subquery that they have graciously provided to us. So if we think about how this is going to execute, the subquery is actually going to go first, and it needs to be inside of parentheses, I believe. Yes. The subquery is actually going to execute first. It's going to run this select statement first. Whatever value it comes up with, it's going to plug in to the insert query, the outer query, and then it will execute that outermost query. So you might actually see your subqueries formatted a little bit differently. Some people like to format them as closely as possible like this, right? Where it looks kind of like a select query over here on the side. But yeah, it's just going to pull out the plant ID, substitute it right in for the foreign key there. Let's run it and see if it works. Oh, it's seed, not seeds. My fault. Incorrect date value. All right, cool. I think it wants dashes, not slashes, right? No? Does it want year, month, day format? What does MySQL want? There we go. Yeah, it wants year, month, day. Perfect. Got it. And so if we take a look at our seed table now, there it is. And the plant ID it found is 1, and we can actually verify that by going to the plant table and looking at the plant ID for hosta, which is in fact 1. All right, cool. I think that, not to beat a dead horse, I think that this really should just be done with a 3-table join. I'm not sure where the subquery comes into play, but if any of you have a solution for this that you'd like to chat about, I'd be happy to chat with you about it. Otherwise, I am gonna shut up. I went over my time a little bit. Sorry about that, but I did want to show at least one subquery, and I succeeded. During the next catch-up day, I would love to do these bonus missions, especially since there's one about Union. But for now, oh, we got a subquery. Plant ID, plant name from plant. Oh, yeah, there you go. Let's look at this because I think this is good. Thank you for sharing. I know that I said that I was going to shut up, and yet I'm still yakking on, but I like this. This is good. This is a good example of how you could solve this using a subquery. So here is the join that I'm betting a lot of people used for the first part of this. There we go. And they are tacking on this outer query that uses, this is a very common type of subquery where we have a plant ID in a set of plant IDs, right? So this is going to return a set of plant IDs of seeds that are currently in our, that have plants currently in the garden bed. This query then will check every plant ID against these plant IDs that were found in the subquery. The subquery always gets executed first, right? And then that information gets passed to the outer query. But for the last, I know I'm repeating myself, but this could also have been done. And actually, we did do it as a 3-table join as well. That's not to say that subqueries are bad or that you shouldn't use them. I actually think the subquery is just fine. But this is an example of where a subquery could be used as a join instead. And there's no problem with doing that. Okay. Gonna shut up for real this time. Thanks, everybody. You've got a studio to work on. I'll be back at 8 o'clock to talk to you about that studio. So have a good one. See you in a little over an hour. Thanks, everyone. Franklin says thanks.